So today our look at ocean circulation brings us to thermohaline circulation. Geologists can measure the temperature and salinity of the ocean in a lot of interesting ways, but one of which is to put an instrument in the ocean that can float at the surface for a while, but then sink down, drift around, and send back by satellite recordings of both temperature and salinity. So you can figure out where it is, what the temperature of the ocean is, and what the salinity of the ocean is at that place. It's one of the ways we've really been able to understand thermohaline circulation. So let's start with the temperature piece. The Earth, of course, is a sphere, and most of the surface heat comes from the sun. So the sun is bombarding us at all times with these waves of radiation, and they are an equal amount. However, because the Earth is a sphere, that equal amount of radiation is spread over a different amount of land. At the equator, the incoming solar radiation is focused on a very small area, while at the pole, that same amount of incoming solar radiation is spread over a much larger area. Therefore, things heat up more at the equator than they do at the pole. So it shouldn't be any surprise that our ocean surface temperature looks something like this, where the warm waters are focused around the equator, much colder waters at the pole, and in between, a gradation from one end to the other. Now, if the ocean wasn't circulating, if there weren't any continents in the way, this would be a very even pattern in color. But of course, we do have continents and we do have currents, and that changes the pattern from a simple stripe to a much more complex stripe. Let's look at how. Here, by the way, is a picture of the Gulf Stream. This is one of the major ways that heat is moved in the Atlantic Ocean, and it's a huge part of the global thermohaline circulation system. We'll be talking about what its effects are a little bit later. Here is a map of the thermohaline circulation system, and I know it looks pretty complex. We're going to go through it one piece at a time, but I want to start by focusing your attention on a couple of places. If you look here where it says deep water formation, there are 3 places in the global oceans where water is sinking, and that's because the water is cold and it's salty, and therefore it's more dense, and it sinks to the deep ocean basin in the northern Atlantic and in the southern ocean near Antarctica. That deep water formation, the sinking of water into the deep ocean, is really important because it allows for water to come up from the deep ocean in other places on Earth. So here in the Indian Ocean and again in the Pacific. So those places where ocean water sinks and ocean water rises are how the deep currents and the surface currents are linked together. We'll start with the northern Atlantic and look at where the ocean water is sinking. Right off there near Greenland, in the northern Arctic Ocean, you see that water is forming the deepest part of the thermohaline circulation system. It sinks there, it comes south through the Atlantic all the way down to the Southern Ocean, where the current continues towards the east. And then it is diverted in a couple of places into the Indian Ocean and into the Pacific Ocean, still very deep at the bottom of the ocean basins. But in both the Indian and the Pacific Ocean, the water begins to rise up towards the surface and joins the surface currents. And those surface currents then are linked together across the globe, coming from the Pacific through between Indonesia and Australia into the Indian Ocean basin, down south of Africa and up into the Atlantic, and around back into the northern Atlantic Ocean, where by now it has cooled off and is sinking again in the northern Atlantic. So one large circulation system. This thermohaline circulation system is one of the main mechanisms for redistributing heat on the globe. And that, if you look in the North Atlantic, you can see that nice warm water moving across the North Atlantic. It's one of the reasons why St. John's, Newfoundland is much colder than London, even though they're at about the same latitude, because all that nice heat is being carried over to Europe and leaving Newfoundland cold in its wake. So that's it. the Great Ocean Conveyor Belt, or more formally, thermohaline circulation.